Good day. So today I'm going to go over the worksheet, the chemist sentence. I'm going to start off with the two examples that are given. So the first thing we want to do is just figure out what's going on. So when you read this, you're looking for certain types of words that's going to help you out. Obviously, there's going to be the chemicals itself. So I'm going to underline them. So you have calcium hydroxide, you have hydrochloric acid, you have water, and then you have calcium chloride. So those are the three or four things that we're going to have. The next key is to see where is the before and after, where is the reactants, which eventually turn into the products. So there's a couple words that you're going to see. Yield is probably one of the most obvious one because it is like the product of or anything like that. So I'm going to circle that one. So yielding is where our arrow is going to be. So what I'm going to do is I'm going to write each chemical, and then I'm going to write an arrow in between, and then what we want to do is figure out how to balance the equation. So first, let's just write it all out, not worrying about balancing the formula or the equation. So I'm going to have calcium, Ca, and I'm going to have hydroxide, which is OH. Then I'm going to have hydrochloric acid, which is just HCl. And then we have yield, which is our arrow, water, H2O, and solution of calcium chloride. So like I said, I'm not going to worry about the charges yet until I got at least the chemicals now. Now you're going to look up, either you memorized it already or just look at a periodic table. Calcium has a charge of 2+, hydroxide have a charge of -1, HCl positive, negative, H2O is already balanced, it's not an ionic compound, and then calcium again is 2+, and chlorine is minus. So then we're going to balance it out. So you have 2 plus here, 1 minus here, so you want 2 of these. So 2 times -1 is the same as 2 plus. And also it's the same here, 2 plus, so you need 2 of these. Now that you want to balance out the equations. So usually what you want to do is, it doesn't really matter what order most of them is, but you usually want to save for last hydrogen and oxygen. So these are always the last ones you want to do. So I'm going to avoid the H's, and in this case the O's and the H2O and the OH's. So let's look at it. Another thing that you want to look out for is if you have a polyatomic ion. So right here we have a polyatomic ion. If possible, keep it together. So if I saw like an OH on this side, I would count them together as OH. So a lot of times that makes it a little bit easier. In this case, I don't see a OH on the other side, so I'm just going to ignore that. But in another example, we're going to see a polyatomic ion, and you just want to keep them together. Okay, so I'm going to start off with just calcium. Okay, so I'm going to label all my elements in the middle. I have calcium. The next one I want to do is chlorine. You could do chlorine first. It doesn't really matter. It's just, and I'm just doing the order of that. Then I'm going to do hydrogen, and then finally oxygen. I'm going to write down in the middle. That usually helps me figure out which one I want to go at. I'm going to write the number on the left side and the right side. On the left side right now I have 1 calcium. On the right side I also have 1 calcium, so it is balanced so far. On the left side I have 1 chloride, and on the right side I have 2. So it's not balanced now. So what I want to do is balance it out. So I'm going to put a 2 in front of HCl. That means I'm going to change this now to 2. And it doesn't affect anything else because what's in front of it is H, which we haven't counted yet. So it didn't affect the calcium on either side. Okay, now the next one is H. I have 2 times 1 here, so I have 2 H's here, and then I have 2 H's here, so a total of 4. On this side I have 2 total. And that's it. So the easiest solution is just multiply the H2O by 2. So now instead of 2 I have 4. So now I'm balanced again. So I have the following. Last one is oxygen, and the hope is it's fairly easy at the very end. So by doing all the other ones, oxygen is hopefully already done. Sometimes it's not, but hopefully it is. So right here, let me get rid of these so I don't get it confused. For oxygen, I have 2 times 1, which is 2. So I have 2 OHs, so that's 2 oxygen here. 2 times 2, I also have 2 here. So I am balanced. So there I am. I'm going to rewrite it properly without the charges. I'm going to do it in pink. So I have CaOH2 because you need 2 OHs or hydroxyl groups to balance the calcium, plus 2 HCl yields 2 H2O and calcium chloride. So there is our balance equation. So once again, you just want to write it out, find where the arrow sign is, where the yield is, write out all the ions or chemical formulas, and then balance those first. Then you want to balance the equation. For this one, which is number 2, it's much easier because in the end it's balanced. But I do want to go through the same kind of process with you guys. So once again, I'm going to kind of underline all the things that are going to be either the reactants or products. You have magnesium carbonate, you have sulfuric acid, you have magnesium sulfate, carbon dioxide, and then finally water. The key word in the middle, or the one that gives you the arrow, in this case is going to be produced. So that's where going to be my arrow. So I'm going to write everything out. Like I said, like before, either you already memorized some of the polyatomic ions, or you already know certain things, or look it up. So magnesium carbonate is fairly straightforward. You have magnesium, and then you have carbonate, CO3. And like I said, I try not to worry about the charge initially until I'm just done writing everything out. Then you have sulfuric acid, which is H2SO4. And then you have my arrow at magnesium sulfate. And then I have carbon dioxide, CO2, and then water, H2O. Okay, now is my time to kind of worry about my charge. So magnesium is 2 plus, carbonate is 2 minus, SO4 is already done, Mg is 2 plus, SO4 is 2 minus, and then these are not ionic compounds, they're actually covalent. So here it is, and they're already balanced, 2, 2, 2, 2. So we're good. Like I said, what I want to do now is try to keep polyatomic ions together if we can. Okay, so here I see SO4 on the left, SO4 on the right. So I'm going to keep that together and just kind of isolate that. And if I can, avoid splitting the oxygens in here and just concentrate on the carbonate over here. Okay, so like I said before, we're going to save hydrogen and oxygen for last. So I'm just going to go left to right. Here, first one is magnesium. Then I'm going to do, I don't see carbonate on the right side, so I'm going to do carbon. Then I'm going to do SO4 because I do see on both sides, so hopefully I could just cancel it out. Finally H, and then O. So that's my order of attack that I'm going to do and see if they're balanced or not. So here we go. Magnesium, I have 1 on the left side and 1 on the right side. So right now I'm good. Carbon, I have 1 on the left side, 1 on the right side. So I'm good as well. SO4, 1 and 1. Hydrogen, I have 2 over here. And I have 2 over here. And then oxygen, since I counted SO4 as part of, or the oxygen and SO4 as SO4, I'm just going to ignore them. 3 oxygens over here, 2, 1, 3. So it's balanced and everything's done. We just have to rewrite it. In my last problem, I forgot to write solids and liquids or aqueous. So I'm going to try my best doing it this time. MgCO3, I believe this is just a solid, I believe, because it says magnesium carbonate reacts with sulfuric acid. H2SO4, since it's an acid, most likely is aqueous. Oops, just means that it's dissolved in water. And then you have magnesium sulfate, most likely solid, carbon dioxide, which is a gas, and water, which is liquid. Okay, so there you go. Hopefully that makes sense, but this is kind of how I like to do it. I just go look through it. The only thing you want to make sure is try to save oxygen and hydrogen for last. All right, for number 3. Solid magnesium metal is heated in the presence of oxygen gas. A solid salt is synthesized. MgO, what could it be? All right, so once again, I'm going to underline my elements or my molecules that are going to react. So I have solid magnesium, I have oxygen gas, and it's going to make MgO. The key word here is synthesize, so that's going to be our yield, produce, etc. So I'm going to write that out. Magnesium solid, so I'm just write S just because it's a compound. In the presence of O, is going to make MgO. As a side note, this is a gas, right? It says oxygen gas. So this is a gas, and if it's a gas, what's going to happen is it's going to follow the diatomic rule. So oxygen being what it is, it likes to be in pairs instead of being by itself. So these are all the gases that like to be in diatomic, being in pairs. So I memorize it as Hoff, Bring, Go. So hydrogen, oxygen, fluorine, bromine, and chlorine, they all like to be H2, O2, F2, Br2, Cl2. So as a gas form, they're going to be diatomic, meaning there's two of them. They work in pairs. So I'm going to put a little subscript 2 right there. That's kind of how I memorized it. I believe the other one is have no fear of ice cold bears. Whatever works for you, whatever sticks in your mind, whatever helps you remember the diatomics, do it. All right, as I said before, save hydrogen and oxygen for last. In this case, we don't have hydrogen, we just have 2 of them. So in this case, we just have magnesium and oxygen, and it's going to be pretty straightforward since there's only 2 things. Should be pretty quick. 1, 1 on both sides for magnesium. I have 2 oxygens here, so that means I'm going to put a 2 on this side because I have only 1 oxygen. Then I'm going to work my way back up. Since I changed magnesium, this is no longer 1, now it's 2, so I'm going to go over here. Add a 2 here, and then I'm going to double check again. So I'm going to get a good color. So I have 2 magnesiums, so I'm good. 2 magnesiums, I'm good. 2 oxygens, I'm good. 2 oxygens, so I'm good. So here we have 2 magnesiums plus O2 will give us MgO. All right, this is number 4. So this one's kind of tricky in the sense that it is going to be a funky ionic compound on the right, which will kind of unbalance our equation. But other than that, it's fairly straightforward because there's no hydrogen and no oxygen. You'll later find out why those 2 are a pain in the butt. But for now, we're going to have no oxygen, no hydrogen. So lithium reacts with something to give me lithium nitride. Nitride is just nitrogen, so most likely this is nitrogen. So lithium's one element reacting with another element is going to create lithium nitride. And then my keyword here is form, which will give us the arrow. So I have Li plus N, N will yield lithium nitride. So like I said, I'm not going to worry about the charges until a little later. This is a gas. So if it's a gas, you have to think, okay, is it a diatomic atom? And it is. Remember Hofbrinkel? Hofbring. Oh, I forgot nitrogen in my other one. Ha! And iodine. Alright, I forgot 2 of them in the last one, so I do apologize. So Hofbrinkel. Totally forgot about them. 2. So now we want to balance it. Lithium is fine on its own. Nitrogen is fine on its own. Lithium nitride is something that we have to worry about. Nitrogen is -3. Lithium is +1. So then we want to make sure that we have the right amount. So in order for it to be balanced, I need 3 lithiums to balance out the nitrogen. So I have Li3 and so now we're going to have to try to balance them out. So it doesn't really matter which one you want to go first. Lithium, then nitrogen. So here I have 1 here, 3 here. So to balance it out, I'm going to add 3 on this side. So now it's balanced. Okay. Now here I have 1 here, but I have 2 here. So what I need to do is now put a 2 over here to balance out my nitrogens, right? Because I have 2 nitrogens here, 1 over here. But that kind of screws with the lithium. So now we have to redo the lithium. So 2 times 3 gives me 6. So now I have to change this one. Instead of 3, I need 6. So now I think I'm good. I have 6 lithiums on the left. 2 times 3, 6 lithiums on the right. 2 nitrogens on the left, 2 times N, 2 nitrogens on the right. So there I go. I have 6 lithiums, most likely I believe this is a solid, plus N2 gas yields 2Li3N. Okay, and this should be a solid. All right, there we go. A balanced equation of the reaction for number 4. All right, number 5. When potassium chloride is heated, it decomposes into solid potassium chloride and oxygen gas. So once again, I'm going to underline what I want to know. Here's one thing, here's another thing, and here's the last thing. So there's only 3 this time. The key word is decomposes. So that's going to be our produced, yields, etc. So we were given what chlorate is, which is ClO3. So we have potassium, K, ClO3. I'm going to put a minus there to help me remember. Decomposes, which is my arrow sign, potassium chloride, Cl, and oxygen gas. And whenever you see the gas, you'll have to be careful. Is it a diatomic? And the answer is yes, it is. So now we want to make sure that our molecules are balanced itself. Potassium is a plus, so plus minus, it's good. Plus minus is good. O2 is a covalently bond molecule, so it is balanced molecularly. Now we want to see if the entire chemical formula or the chemical sentence is balanced. So like I said, always save hydrogen and oxygen for last, and if possible, keep the polyatomic together. The polyatomic splits, so we can't. So my order is I'm going to go left to right. That's usually how I do it. Potassium, chlorine, oxygen. All right, potassium 1 1. I'm good. Chlorine 1 1. I'm good. Oxygen 3 2. Not good. So I need to find the best way to do it. Probably, if we want, the lowest common denominator is 6, or factor is denominator 6, so we want to use 3 over here and 2 over here. So 3 times 2 gives me 6. 2 times 3 gives me 6. And now I need to work backwards to make sure my other stuff are balanced. So I have 2 potassiums on the left. So that means I need 2 potassiums on the right. And hopefully the chlorides or the chlorines balanced as well. So I have 2 right here. And then I also have 2 right here. So balanced. So it actually worked out for us. So the final equation will be 2 potassium chlorate yields 2 potassium chlorides and 3 oxygens. Okay, so let's put the labels then. Let's see if it tells us if it's a solid. Yep, this one's a solid as well, and a solid. All right, so there is our balanced equation for number 5. All right, for number 6, I have the following. Lead and lead 4 oxide react with sulfuric acid to produce lead 2 sulfate and water. So once again, I'm going to underline everything that is reacting. So I have lead 4 oxide, sulfuric acid, and they're going to make lead 2 sulfates and water. The key word in this case is produce, so that's where my arrow is. I'm going to write everything out. So I have lead, which is just Pb, Paul Bender, plus lead 4 oxide. So I'm going to write that down. Usually I don't, but since it's already there, I'm going to write 4 plus O2 minus. It's going to react with sulfuric acid, which is from problem 2, H2SO4, and it's going to yield lead 2 plus sulfate, so that will be SO4, and then let's see, water, H2O. All right, so there is my thing. Now I want to make sure my chemical or molecular formulas are balanced. So here I have 4 and 2, so I need 2 oxygens, which will give me 4 minus, so that will be balanced out. Lead is 2 plus here, SO4 is 2 minus, so they are balanced out right there as well. So there is my formula. Like I said, so you want to save hydrogen and oxygen for last, and if we could keep this together, I'm going to try my best to do it. It will make your life easier if you could count it as a whole. So right now it looks like I have both SO4 on both sides, so I'm going to make it do that. So I'm going to read left to right. PB is my first one, PB is my second one, O I'm going to save for last, H I'm going to save for last, SO4, then I'm going to go back to H, and then finally O. So that's my order of I'm going to try to balance. Like I said, if you can keep it as a polyatomic, please do. It will make your life easier. So on the left side I have 1, 2 leads. 1, 2 leads. On the right side I only have 1. So I need to put a 2 in front of this one to give me 2. On the left side I have 1 SO4. Here I already have 2, so I need to put a 2 in front of this one, and now it's balanced. Okay. H's. I have 2 times H2, which gives me 4. Here I have H2, so I need 2 H2Os, which now will give me 4. And you always cross your finger, please, oxygens already be balanced, so I don't have to do any extra work. Here I have 2, right? And we don't count this one because we count it as a diatomic or polyatomic. And here I have 2. Yay! The oxygens are already balanced. So there we go. We have lead plus lead oxide yields, oh, I forgot one, plus sulfuric acid, or else it won't do anything. 2 of them will give us 2 lead sulfate plus 2 H2O. Okay, so there is my balanced equation, and we did it this way. And like I said, if you could keep the polyatomic ion together, it makes it a little bit easier if you do that. All right, for number 7, we have the following. Solid ammonium nitrate decomposes into water and 2 of the most prominent gases in the air. So I'm going to just say that's N2O2. Nitrogen is 80%-ish. Oxygen is about 20%-ish. Technically, nitrogen's like 79, and then oxygen's 21, 78, and then 21, and then 1% other. But whatever, about 20, 80. So we have ammonium nitrate. Decomposes is, I'm going to circle it first just because it's so early. Decomposes is our arrow, and the rest is our products. So we have water, N2O2. So let's do that. Ammonium is NH4 plus, and then nitrate is NO3 minus, and decomposes give us an arrow. Water is a covalent compound, or yeah, nitrogen is a gas, so I already put it there. N2, oxygen is also a gas, which is O2. Okay, so here is my equation. This is balanced. These are covalently bonded molecules, and now we're going to count. So like I said, always try to keep polyatomic ions together if possible, but do not have them on the right side. So we're just going to do it leaving oxygen and hydrogen last. So the first one is nitrogen, then we're going to do hydrogen, and then finally oxygen. All right, let's see how it works. I have 1, 2 nitrogens on the left. I have 1, 2 nitrogens on the right. Nice. Here I have 4 hydrogens on the left. I have 1, 2 nitrogens on the, or hydrogen on the right, so I'm going to put a 2 here. So 2 times 2 gives me 4, and that doesn't really change my nitrogen, so I'm okay. Now I'm going to count my oxygens. I have 3 on the left, which I go, uh-oh, I already know this can give me trouble because of diatomic. So I have 2, let's see, 1, 2, 3, 4. I have 4. Okay, so then you could do a couple things. You can, since it's diatomic, technically put a half right here. So you're allowed to put a half in front of diatomic, which then will give you 2 plus 1 and 3. If you don't like halves, there's another way of doing it. Technically, then you just double everything. So let me kind of undo it and show you how it will be doubled. So that's how it was, but I'm going to do it the other way, which is doubling everything. So right now we have 4. So okay, instead of trying to go crazy, because 3 and 4 is 12, that's a bit of a pain. So if my goal is, let's just make this an even number. In order to do that, I'm just going to put a 2 in front of here. So if I make this an even number, hopefully I could find a way to make the right side another even number. When it's odd, it's almost impossible. So if I put it here, 2 here, I'm already changing this 3 into even number. So 2 times 3 gives me 6. I need to go back and kind of figure out all my other ones. So now I have 2 nitrogens times 2. So instead of 2, I now have 4. So I need to go back to here. Okay, here I have 2. In order to balance that out, I'm going to put a 2 in front of here. So now I have 4 as well. For hydrogens, now I have 2 times 4, which gives me 8. So I need to go here. Okay, right here. So I have 2 here. So instead of multiplying by 2, now I need to multiply by 4, which will now give me 8. Now you just cross your fingers and see if oxygens got balanced naturally. So 2 times 3 gives me 6. Now I have 4 here, and I have 2 here, and go, yes! Magically it balanced out. So if you have odd on one side, remember before it was 3 and 4, instead of finding the multiple, which is 12, try to double up or make this side even first, and then see if it will just balance out. And it worked in this case because we have 2 sources of oxygen, so you can kind of manipulate them. So that's the easier way. So here is my now balanced equation. So I have 2 ammonium nitrate, which will give me 4 water molecules, 2 nitrogen gas, and 1 oxygen gas. So there it is. Let me see. It doesn't really make us, I'm assuming this is a solid. Yep, it's a solid. Water is a liquid. These are gases. There we go. Okay, this one's a little wonky just because of where the produced is, but we're going to do the same thing. Nitric acid, ammonium hydroxide, water, and ammonium nitrate. The produce is at the end, but you'll notice that there's a period, so technically you could put it right here. Nitric acid, ammonium hydroxide are mixed, producing water ammonium nitrates. So just be careful here, even though it's at the end, because of the period, it really is right there. So nitric acid is HNO3, ammonium hydroxide is NH4, OH, and then we have the arrow, which is the produce. We have water, and then ammonium nitrate. Okay, let's make sure everything is balanced. This one is +1, -1. That's the compound, again, +1, -1. So we're all happy. Like I said, if you can, always leave hydrogen and oxygen at the end, but if you keep a polyatomic molecule together, do it. So notice that I have a polyatomic right here, polyatomic right here, polyatomic right here, right here, and right here. So looking at it, my OH, my hydroxyl group, does not appear on the right side, so I can't do that there. But I do have NO3 on both sides. I have NH4 on both sides, so that's what I'm going to do. I'm going to keep them together if possible. So here's my list. NO3, then NH4, and then H, and then O. So that's my order. Then I'm going to balance it. NO3 or nitrate looks like it's 1, 1. 1 here, 1 here. Ammonium, 1, 1. So I'm good. Now I'm going to tackle, let me erase, let me see if I could just erase this one since we're not, there we go. Since it's not preserved on both sides. Now I'm going to do hydrogen. I have 1 right here, 2 right here. I'm going to ignore this one right here because it's within the polyatomic. So I have 1, I have 2. So I'm going to count the other side. Oh, I have 2. Perfect. Is it going to be balanced? Hopefully, fingers crossed. One here, one here. I'm good. So it's balanced. So notice that if you keep it polyatomic, if possible, makes it a little bit easier just because you count them together, 4 NH, 4 here, and then kind of keep things more simpler. So instead of having like N, O, H, and then you're just all over the place, you keep it together. So there it is. So here's the balance equation. H NO3 plus NH4OH yields H2O plus NH4NO3. Okay. All right, for number 9, I'm going to take my time here. So this one might take a little while. And the reason is because it's both balancing equation and what we did in class, which is the Sorcerer's Stone. We're going to have a precipitate. So I'm going to try to teach both at the same time. Hopefully it'll make sense. So first, let's just write the molecular equation, Me. So that's what we've been doing. So I'm going to underline what we already have. We have the reactants, lead, 2 nitrates, potassium iodide, and we're going to, the arrow is already done for us. There it is. There's the arrow. And it's going to produce lead 2 iodide and potassium nitrate. So we're going to kind of ignore everything else, but those are our things. So let me write that out for us. So we have lead, Pb. I'm going to write the charge just because it's given to us. Nitrate is NO3. Then I have potassium iodide. Then I have a solid precipitate of lead. Oh, let me draw my arrow of lead, Pb2, iodide, I, and then potassium K nitrate, which is NO3. Now, after I'm doing that, I'm going to make sure my chemical formulas are balanced. So I have lead 2 nitrate. Nitrate is a -1. So then I need 2 of these to balance it out. Potassium is +1. Iodide is -1, so it's good. Lead is 2 here. Iodide is -1, so I need 2 of these to balance it out. And then here's plus and then minus, so it's good. So the molecular formula is the following. You have a solution which is PbNO3 plus Ki yields PbI2 plus KNO3. So if I'm going to label it, this is aqueous, aqueous, solid, aqueous. So let's make sure the equation is balanced. So like I said, always save oxygen and hydrogen at the end if possible. If we could keep the polyatomics together, please do. So here we have one polyatomic, which is NO3. It's on both sides, and we keep it together. So lead, NO3, potassium iodide. So let's look it up. 1, 1. I have 2 here. I have 1 here, so I need to put it 2 in front of here, which changes to 2. I have 2 potassiums on the right, so that means I need 2 potassiums on the left. And then I have 2 iodines and 2 over here. So balanced now. This is our molecular equation. This is what's happening. You have an aqueous solution with another aqueous solution, which then creates a precipitate, which is a solid, and then spectator ions, which is here. So if we want to do the next one, which is the total ionic equation, or TI, is what's actually happening. So when you put lead nitrate into water, it's going to dissociate in both its lead form and its nitrate form. So instead of it together, you could write it like this. Let me change the color. You could write it like this. So Pb as an ion, it's 2 plus nitrate, which is NO3 minus. But right here shows us that we have 2 of them. So I'm going to put a 2 right here. Then I have the following one. I have potassium and then I have iodide. Here, this is -1. This one is +1, and we'll make sure we have the coefficient correctly. So I'm going to put a 2 in front of both of them. So that's what we have initially. When they're mixed, we're going to get a precipitate, which is PbI2. Since this is a solid, it is together. Lead likes iodine, or iodine more than water, so they're bonded together. And then you have potassium plus and NO3 minus, and here we have 2 of each, 2, 2. So this is the total ionic equation. We're going to keep the things that are going to be dissolved and dissociated in water as ions. So that's why all of these are ions on the left side. The precipitate, since they're not dissociated and dissolved in water, they're now a solid and creates turbidity in the water. It is now solid. We're going to keep it together. The potassium and the nitrate is now out. Now the last one, which is the net ionic equation, is we exclude the spectators. So spectators are ions that are both on the left side and the right side that really aren't involved in the reaction. PbI2 is the reaction. They're going to come together. So you'll notice that NO3 is on both sides of ion, so they are a spectator, so we get rid of them. Potassium as well, spectator, so we can get rid of them. So there, the only thing that's left is PbI2. So I'm going to kind of undo my blues so we can have all of them at once, but that's what I'm going to highlight. So once again, Pb2 plus 2I1 minus will yield PbI2. So this is my molecular equation, my total ionic equation, and then my net ionic equation. So like I said, I took a little bit more time here. Pretty much right here is balancing the equation, but I want to go a step forward since we kind of went over this and the sorcerer star. All right, I had to Google this one, to be honest, just because I didn't know what mom is. But if you Google it, it is milk of magnesium. So that will help you fill in the blank. In this case, milk of magnesium, let me make sure I got the right place, is magnesium hydroxide. So I'm going to write magnesium oxide. Vinegar is acetic acid. And now you have to be careful on this one because it's backwards. So magnesium acid is the salt produced. So this is kind of the product over here when these two are the reactants. So just be careful. That is that one. There's my produced acetic magnesium hydroxide and water. So just really be careful. It's kind of in funky order. Here's my reactants right here and here. Here are my products. So just be careful when you do that and read it carefully. So I'm going to start with these two. Acetic acid is HC2H3O2, and then it reacts with magnesium hydroxide, which is MgOH. Once again, I'm not going to worry about it till a little bit later. Produce is my arrow sign. Magnesium acetate, Mg, and then C2H3O2, and then water, H2O. Okay, now I'm going to worry about balancing my molecular formula. This is -1, this is +1, so it's good. This is 2 plus, this is 1 minus, so I need 2 of these. And the same thing here. This is 2 plus, 1 minus, so I need 2 of these. And then this is a covalent molecule, so we don't have to worry about it. So now we want to balance it. Like I said, save oxygen and hydrogen at the end. If we could keep polyatomic ions together, let's do it. Notice, this is on both sides. So guess what? I'm going to be lazy. I'm going to try to keep it together. C2H3O2. So look, it even has the very annoying hydrogen and oxygen. So if we could keep it together, let's do it. Magnesium is next. hydroxyl group. Do I have it on both sides? Unfortunately, we don't, so we can't do it. Then my normal order is H and then O. So that's how I'm going to tackle it. I have 1 on this side, 2 on this side. So I'm going to put a 2 in front of this. Oh, wrong one. I'm going to put a 2 in front of this one. So now I have 2 on the left, 2 on the right. Magnesium. 1 here, 1 here. So I'm good. 1, 1. All right. Hydrogens. 2 right here, and that's it. Oh, never mind. I have 2 here. And then since I do not have hydroxyl group on both sides, I have 2 over here, so total 4. Here I have 2, so I'm going to put a 2 in from here to give me 4. Now you always cross your fingers to make sure that our oxygen is balanced. So here I have, let's see, get rid of this. I have 2 oxygens on this side, and I also have 2 on the right, so I am good. So there we have it. That's balanced now. So we have 2 H C2H3O2 plus MgOH2 yields MgC2H3O2 plus 2H2O. So there we have it, balanced equation. All right, for number 11, here we have solid zinc is placed into hydrochloric acid, hydrogen gas is produced, and a solution of, most likely it's going to be zinc, because that's what we started with, chloride remains. So, zinc, hydrochloric acid, produced, solution of zinc, chloride, and, oh, I left the one, hydrogen gas, H2. So there it is, make sure it's balanced. Zinc, it's by itself, so it's good. Hydrochloric acid, it's good. Zinc actually has a charge of 2+, so I need 2 of these, and H2. So now we just want to balance it. Save hydrogen and oxygen for last, so I have zinc, chlorine, hydrogen. So it looks like I don't have to do too much work. 1, 1, then 1, 2. So I'm going to put a 2 here. And then now I have 2, 2. So there we have it. Very simple. This one is done and done. For number 12, this is a combustion equation. So you have a fuel, which is C5H12, and it is burning. If you didn't know, you need oxygen in order to burn. And the byproducts, if it burns cleanly, is just water and carbon dioxide. So if you didn't know, a clean burning fuel only produces those 2 as products. You don't really get any soot. If it's a big carbon change, you might. But pentane is pretty short. The gases that we burn in our house are methane, which is 1 carbon, propane, which is 3, which is probably what you have in those big tanks. And if you have a little like stove, it's butane, which is 4. So most of those are pretty clean burning, which means that you only get water and carbon dioxide. It's only when you really get big chains of hydrocarbons, like diesel fuel, is when you kind of get like those big poofs of soot that comes out. All right, like I said, when you're balancing equations, you want to save oxygen and hydrogen for last. In this case, we only have 3 elements. We have carbon, hydrogen, and oxygen. So that's the order I'm going to balance it, and we'll see how we go. On the left side, I have 5 carbons here, and I have 1 carbon there, so I'm going to put a 5 here. On the left side, I have 12 hydrogens. Here I only have 2, so I'm going to put a 6 in from here. So now I have 12. Now I have 2 oxygens on the left, and I have, let's see, 5 times 2, which is 10. Then 6 times 1, which is 6. I have 16. Oh, but what's nice is it's an even number, so it makes it easy. 8. So now 8 times 2 gives me 16. So you could double check. 5, 5, 12, 12, 16, 6 times 1, 6, 5 times 2, 10, 16. So there we have it, balanced equation. So usually that, as long as you go save hydrogen and oxygen for last, it makes life much easier. For number 13, we have the following. Solid potassium bicarbonate decomposes, so that's the key word, to produce solid potassium carbonate, water vapor, and carbon dioxide. Okay, so I'm going to write that out. Potassium bicarbonate, HCO3 minus. There we go. Yields potassium carbonate, CO3, and then you have water and carbon dioxide, CO2. There we go. Make sure that it's balanced. This one is minus plus, so it's good. Since we lost H here, this one's 2 minus, so this needs to be 2 here, so that will balance us out, and the rest are covalent molecules. So like I said, if we could keep it as a polyatomic, we can. It looks like we can. Let's see. No, we can't. So the order that I'm going to do is potassium, carbon, hydrogen, oxygen, and we're going to try to balance it out that way. Okay, potassium, 1 and 2. So here I have 1, here I have 2, so I'm going to put a 2 here. So now it's balanced. So now I'm going to go with carbon. 2 times 1 is 2. Here I have 1, 2. So here I have 1, 2, so I'm balanced here. 2. H's, 2 times H is 2. Here I have 2 here, 2. So I'm good. Cross my fingers, this is all we have. 2 times 3 gives me 6. Here I have 3, 1, and 2. Yes! Easy. Done. That's it. Okay, so we got lucky here. All we had to do is put a 2 in from here. Let me look at my answer key to make sure I'm good. And I am. So there is my balanced equation. Alright, number 14. Magnesium is added to copper 2 chloride to produce copper and magnesium. Well, most likely chloride. Alright, here we go. So magnesium, copper produces copper and magnesium chloride. So we're just going to switch the metals. Magnesium is Mg. And it's going to react with copper, 2 plus, chloride, 1 minus, yields copper metal and magnesium, and that is 2 plus, chloride, 1 minus. Okay, balance the molecular formula first. Mg's by itself. Since this is 2 plus, we need 2 chlorines to balance it out. 2 times 1 gives me that. Copper's by itself, we don't care. Here's 2 plus, so we need 2 here. No oxygen, no hydrogen, so whatever order you want. I'm just going to read left to right. Magnesium, copper, chloride. So 1 on the left, 1 on the right, 1, 1. 1 on the left, 1 on the right, 1, 1. 2 on the left, 2 on the right. Balance. So this one was fairly straightforward. As long as you balance the molecular formula, you are good to go. Alright, here is 15. I'm going to go a little bit faster since I'm approaching 1 hour. Acetic acid is neutralized by sodium bicarbonate. Water, carbon dioxide, and a solution of sodium acetate are produced. So let's write it down. Here is acetic acid, which is H, C2H3O2. And it's going to react with baking soda, which is Na. Ooh, my handwriting's getting bad. Sorry about that. NaHCO3. And that's going to give us water, carbon dioxide, and sodium acetate, C2H3O2. So, like I said, save oxygen and hydrogen for last. If we could keep the diatomics, or not diatomics, the polyatomics together, we can. I see acetic acid or acetate on both sides. I do not see bicarbonate on both sides, so we can't do that one. So I'm going to do C2H3O2 first. sodium, then carbon, then hydrogen, and then oxygen. So that's the order I'm going to work with. I think I got everything. Looks good. 1 on the left, 1 on the right, 1, 1. 1 on the left, 1 on the right, 1, 1. Carbon, 1 here. Carbon, 1 here. Hydrogen, 1, 2. So 1 right here, 2 right here, 2 right here. And I'm good. Ooh, cross fingers. Do I have everything balanced? I have 3 on the right. Oh, 3. And oh, look at that. 3 on the left. Or right, sorry, right. So we are good. That's it. Don't have to do anything. All right, number 16, potassium metal. Potassium metal is placed into water, produces hydrogen and a solution of something, hydroxide, so most likely it has to be potassium. All right, let's write it. Okay, potassium metal, which is KS plus water, which is H2O, which is a liquid, produces hydrogen, which is a gas, and you have to be careful. If it's a gas, that means it's going to be diatomic, H2, and a solution of potassium hydroxide, so that is potassium OH, and this is going to be aqueous because it's a solution. All right, so there we go. Now we're going to count left and right and make sure that is balanced. Remember what I said is if we save H and O till the end, and if we have any polyatomics, then we will save it, but we don't. So we're going to do potassium, hydrogen, oxygen. So that's the order I'm going to do it in. 1 potassium on the left, 1 potassium on the right, 1, 1. I have 2 hydrogens on the left, 2, 3 hydrogens on the right. So since this is an odd number, I'm going to double it to kind of hope for the best. So if I double it, now this is 4. So I could match that with also a 2 right here, which will give me 4. So whenever you have odds, double it, make it an even, and hopefully you could kind of even out on the left side or the right side. It doesn't really matter. So let me make sure I didn't affect my potassium. I did. So since I put a 2 here, the potassium now is 2. So then I have to put a 2 in front of this one, which will balance it out. So let's start all over. I have 2 potassiums on the left. I have 2 potassiums on the right. I have 4 hydrogens on the left. I have 1, 2, 3, 4 hydrogens on the right. I have 2 oxygens on the left and then 2 on the right. So now I am balanced. So there you go. All right, I'm going to finish within an hour. The last one that we have is the following. So this is number 17. Yeah, Tom's getting tired. My handwriting's getting horrible. All right. We have mercury, Hg2, 2 plus, nitrate, which is NO3. It's heated, it decomposes, so that is my arrow sign. And it's going to form a solid mercury, so that's Hg, and it's still 2 plus. Oxide, O. The gas nitrogen dioxide, which is N. Dioxide, which means 2 O's. And the number 2 air, which is oxygen, but that is a diatomic, so it's 2. So here we go. Let's make sure that our ionic compounds are balanced. Hg is 2 plus, NO3 is 1 minus. So I need 2 of these to balance it out. And oxide is 2 minus, so we're good on the right side. So let's start it up. As always, we want to save hydrogen and oxygen as the end. Start off with mercury, nitrogen, and oxygen. Here we go. 1, 1. Nitrogen, I have 2. NO, 1, so I'm going to put a 2 in front of this one. Doesn't affect my mercury. Then here I have 2 times 3, which is 6. 1 plus 4 plus 2, 7. So you're like, oh, that sucks. Like I said, you could put a half here, which will give you the right answer, but you could take your time. So 1, 4, 2, which gives me 7. Odd number, yuck. All right. Since this is going to give me an even number, what I'm going to do is I'm going to put a 2 here because that's the only thing I could do. And I'm going to, or you could do the opposite. You could put a 2 in front of this one and kind of work backwards because you want to get rid of this number. Now if you put it here, 2 here, you get 2, 4, and 2, so that gives me 8, which doesn't help. So like I said, eventually you're just going to put a 2 on this side. Let's see if that helps. So now we have to work all over. So I'm going to just erase everything and kind of start from scratch. So I know I need to have a 2 on the left side to kind of even it out. So I'm going to do here 2 H's, or sorry, 2 mercuries, and then 2 mercuries. I have 2 times 2 nitrogens, so that's 4 nitrogens on the left. So that means I need 4 right here. Good. Oxygen, I have 2 times 3, which is 6, times 2, which is 12. Then I have 2 times 1, which is 2, 4 times 8, which is 8, or sorry, 4 times 2, which is 8, and then I have 2. So 2 plus 8 plus 2 gives me 12. I am good. So there we go. Balanced and good to go.